Hey guys, today we're going to talk about the respiratory system. And then to start, we need to go over the anatomy, right? Just memorize this. So it goes from your nares, then your pharynx, larynx, trachea, bronchia, bronchioles, and then alveoli. Okay, and then your alveoli is going to be the site of your gas exchange, and then you need to know that this is covered in capillaries. So the mechanism of breathing. Okay, so this was actually on my actual MCAT. So when you inhale, okay, your diaphragm and intercostals. Your intercostals are just another word for your ribs. So your diaphragm and your external ribs contract, and then this causes negative pressure in the lungs. And then when you exhale, it's passive or active, and this is again using your intercostals. So lung volumes, we have tide volume, residential volume, viral capacity, and then total lung capacity. And I will say, when I was originally studying for my MCAT, this was something that was so hard for me to understand, right? Because each of these would do something different. But I never saw this on any full length or even on my real exams. So take that with a grain of salt if you want. And then your medulla oblongata monitors your CO2 levels, and then we do that via your chemoreceptors. And then now gas exchange. So CO2 and O2 move by diffusion across partial gradients, really meaning that we move through open slits and capillaries. HB means hemoglobin, by the way. So HbO2 binding is regulated by your pH, CO2, temperature, and then 2,3 BPG, which you guys should know from biochem. 2,3 BPG increases the affinity for hemoglobin. And then 6.4, last but not least. So we have thermoregulation, okay, and we do this via vasoconstriction and dilation. And then for those who don't know, thermoregulation is just how we control temperature in our body. Okay, and then your immune defenses. So these are like hair cells here. And then you also have your mucus, macrophages, and mast cells. And your mast cells release histidine. And then this is the equation for pH control. And then this I would definitely commit to heart. And then you should understand, like, if we had let's say we increase CO2, right? For once, let's just ignore this. If we increase the amount of CO2 we have, you should know Lissatier's principle is going to take the equilibrium arrows that way, okay? You should definitely know that, right? Because I've seen questions. So, like, if I were to decrease the amount of bicarbonate, then the equilibrium would go this way, okay? So that's it for the respiratory system. I'm not sure what system chapter 11 is, but I mean chapter 7, but I've seen chapter 7.